Hello students, as we start dealing with the topic metals and non-metals, we should be aware of a few things. First is nature of bonding of elements. That is the basic thing to understand about metals and non-metals, especially the chemical nature of metals and non-metals. So let us try to go a little bit back to bonding types and nature of element while they are forming bonds, chemical bonds. Now let us see. I have written sodium, which has got 11 electrons and its electronic configuration is 2, 8, 1, and chlorine I have written whose electronic configuration is 2, 8, 7. As you know, in chemical bond formation, atoms of element want to get their octet complete. That means they want to have their outermost orbit containing 8 electrons. Now here see, when you look at sodium, if it will lose one electron, then it will have this one, this orbit as the outermost orbit, and then its outermost orbit will contain 8 electrons. Whereas if you see chlorine, then chlorine will have to gain one electron. You may ask, it can lose 7 electrons, then this becomes 8, but your common sense will tell losing 7 electrons will be difficult. So chlorine will have a tendency to gain electron to get its octet completed. That means its outermost orbit will contain 8 electrons. Now really the bond formation between sodium and chlorine takes place that sodium loses one electron to chlorine. That means sodium atom itself is an electropositive element, atom. What are electropositive atoms? Atoms which lose electrons during bond formation. And chlorine is an electronegative atom because it gains electron during bond formation. Now here only the concept of metal and non-metal comes. A metal is an element the atoms of which have a tendency to lose electron. So that means sodium is a metal and chlorine becomes the non-metal because it has got tendency to gain electron. Now there is something else in a non-metal also. Chlorine, if it doesn't come near to a metal, itself it has got 7 electrons in outermost orbit. It will find out another way, but first let us complete formation of sodium chloride. What happens? Sodium, which is a metal atom, will lose an electron. So it will have positive charge on itself because you know there are 11 protons and 11 electrons in sodium atom. One electron goes, that means number of proton increases, so it forms positive ions. Chlorine has got 17 electrons and 17 protons, but the electron from sodium makes it 18 electrons and 17 protons. That means chlorine will now have a negative charge and the bond formation takes place, and this type of bonding between sodium and chlorine is an electrovalent bond or an ionic bond, which we have studied in the bonding chapter. We do not write the ionic form when we are trying to write the formula of sodium chloride, and this happens. So that means the reaction with a bond formation between a metal and non-metal will result into ionic bonding. Further for bonding chapter you can see electrovalent bonding or covalent bonding in my videos, but I was talking about chlorine atom. Now chlorine is a non-metal, so non-metal will gain electron as well. One more thing can happen. Chlorine has got 7 electrons in its outermost orbit, so I am just drawing an electronic dot structure depicting the state of a chlorine atom. It has got 7 electrons in its outermost orbit. Now another chlorine atom will come. I will intentionally make it as a cross. So this chlorine atom also has got 7 electrons, and here what will happen? Sharing of electron of the outermost orbit in chlorine atom takes place in such a way that both of the chlorine atoms outermost orbit will contain 8 electrons. 2 to 4 to 6 to 8 for this chlorine atom, 2 to 4 to 6 to 8. So there is a covalent bond. So here these are non-polar compounds. Covalent bond is formed by sharing of electrons, especially among the non-metals. So non-metals definition will be, non-metals are atoms the element of which have a tendency to gain or share electrons, where metals are atoms which have a tendency to lose electron during bond formation. That means what is expected in the electronic configuration of metal, that is very, very important. If you will have a look, then what will happen? If you see sodium will contain 2,8,1, that means 1 electron in its outermost orbit. Magnesium will contain 2,8,2, 2 electrons in its outermost orbit. Aluminum will contain 2,8,3, 3 electrons in its outermost orbit. So when I am discussing about aluminum, 2,8,3, to complete its octet, either it has to lose 3 electrons or it has to gain 5 electrons. So what is an easier process? To lose 3 electrons, and therefore all those elements which have a tendency, the atoms of which have a tendency to lose electrons are metals. Alright, so generally when you are looking at electronic configuration, if you are good at electronic configuration, making electronic configuration, you will recognize which is a metal and which is a non-metal. For example, if somebody gives you calcium, say for example calcium, so calcium, you have to only write the electronic configuration 2,8,8,2. If you are good at writing electronic configuration, you will see its outermost orbit contains 2 electrons. That means if it loses 2 electrons, this becomes the configuration of Ca plus 2. That means calcium will lose electron. You can always have an argument it would have gained 6 electron, but your common sense will say in energy consideration and other aspects of bond formation, losing 2 electrons for calcium is easier, and therefore calcium is a metal. So this is one of the things which you have to understand. I have written a whole lot of configuration, and you also have to understand that generally when you will see electronic configuration of metals, the valence electron will be 1, 2 or 3. That means the outermost orbit of metals will contain 1, 2 or 3 electrons. Now here there are 1 or 2 exceptions, to be very sure, like hydrogen's atomic number is only 1. Therefore hydrogen will contain 1 electron in its outermost orbit and the only electron in its orbit. So but hydrogen is a non-metal because during the bond formation it either gains or it shares electrons. So that is there. Normally it will share or electrons. And helium is an inert gas. Helium, normally noble gases can be considered to be not a metal. So helium is not a metal, so we'll call it non-metal, right? Then when you look at the configuration of non-metals, what happens? Their outermost orbit will contain 4, 5, 6, 7 or 8 electrons in their outermost orbit. See, we will include noble gases in non-metals because noble gases are gases, and combining all the properties of a metal, we do not find anything matching there with metals. So noble gases also can be considered as non-metals. So that is the first part which you have to understand. That means in a smart way, in general way, when we speak, then metals will have 1, 2 or 3 electrons in their outermost orbit. Exception is hydrogen and helium. And non-metals will have 4, 5, 6, 7, 8 electrons. However, there is another exception. When you are dealing for board examination, the general question will come. But when you are dealing with competitive examination, or some teacher may ask you that, hey, listen, tin has got 4 electrons in its outermost orbit, but you should know that tin is a metal, for which your answer should be that the definition which we have given for metal, the definition for metals which we have given in the beginning is the metals are elements, the atoms of which have a tendency to lose electron. Now see, this is orbit 1, this is orbit 2, this is orbit 3, this is orbit 4 and 5th. That means the tin atom is a very big one, with very big atom with nucleus here, and then first orbit containing 2 electrons, second containing 8, third containing 18, fourth 18, and then you move to the last orbit. So that means the last orbit is very, very far and therefore the electrons are very far from the nucleus, so even 4 electrons can be readily lost, and therefore the larger metal atoms may contain 4 electrons. That is why the main definition for metal is metals are elements, the atoms of which have a tendency to lose electron, whereas non-metals are elements, the atoms of which have a tendency to gain electrons or share electrons. So here we are there with the chemical property, one of the chemical property or the nature of bonding type in metal and non-metal. That is where metal and non-metals are entirely opposite and different. Now then we come to the physical properties of metal and non-metals. So first thing is that I have got I think so I've got almost a metal being used here in this scissor. So metal are normally solids at room temperature. I've got aluminum metal over here, I have got copper over here, I've got copper. So these are solids at room temperature. Metals are generally solids at room temperature, with mercury being the exception. Mercury is a liquid metal. So otherwise metals are solid at room temperature, number one, that you have to understand. And metals, if they are solid, that means they will not melt at room temperature, isn't it? So metals have got very high melting and boiling point. Iron is somewhere above 1500, 27, 28, or you can check check the list from a reliable source. You will get it is over 1500 the melting point of iron. Aluminum is over 900. So the melting point and boiling point of metal is very, very high. Exception being the mercury, which is a liquid at room temperature, that you have to understand. So first of the basic physical property and the difference between a metal and a non-metal is that metals are solid at room temperature and the only liquid metal is mercury. Non-metals are solid and gaseous at room temperature, and the only liquid non-metal is bromine. Now non-metal, when you try to guess, you should also not guess, you should know the name of non-metals. See all the gases: hydrogen, nitrogen, oxygen, and then fluorine, chlorine, all these are non-metals. So non-metals are normally gaseous at room temperature. Phosphorus and sulfur are solids. So some of the non-metals are solids also, and only liquid non-metal is bromine. So physical state, but for metal there is only one way, they are solids, all right, except mercury. There is no gaseous metal at room temperature. Now next one is metals are hard and heavy. As you know, they are hard and heavy, and that means they have got high density. What is density? Density means in a given volume how much of oxygen you can contain or how much of iron you can contain. Obviously if you will take a big box of measurement 1 meter length, 1 meter width and 1 meter high, and if you pour in iron over there and if you pour in oxygen, then obviously you will have the iron having a lot of mass of iron can be contained in 1 meter cube space, where a little mass of oxygen can be contained in 1 meter cube space. Therefore non-metal and metal, if you compare the density, metals have got very, very high density. This is because the metal ions are very, very closely packed. So that is there. Then there is a property called malleability. You know, you at home your mother may be using silver foil to pack your food. So metals are malleable. That means they can be hammered to very, very thin sheet, so thin that you can tear this sheet like a paper. And some of the sheets can be thick. You see these sheets are used to make shades, etc., or gates. Then that means malleable. Malleable means the metals can be hammered to thin sheets, all right, which serves various purposes. Then metals are ductile. That means if you take a copper piece and then you can draw wire, you can make very, very thin wires. you can make very thin wires of copper. So ductility means metals can be drawn into wire. But if you pull a solid non-metal, it is brittle, it will break. It will not be drawn into wire. So that means the non-metals are non-malleable, non-ductile. Also, when you hit one metal with another metal, then you will get a very good sound, all right, like your school bell. No, then tring, that sound comes, isn't it, your school bell? So that is a metallic sound. That means metal are sonorous. When hit by an object, they make a very pleasing sound, they say, sonorous. Whereas non-metals, I am talking about metal once again. If I have used metal, metals are sonorous. When they are hit with an object, they make very good sonorous sound. Non-metals are brittle. If you hit them with something, they will break into pieces, small pieces. Then you have seen ductility, you have seen malleability, you have seen, and then as soon as I talk about wire, what do you think? Why this wire is being used? Wire is used for conduction of electricity. So metals are very good conductor of electricity. Even for heat, metals are very good conductor of heat. All right. So and that is the electric wire. First, electric wires which we use. The electric is transmitted from electrical power plant to your home through aluminium wire, and because that is little cheaper also, and copper wire inside your home we use. Even gold is very good conductor. It's and gold is also very ductile. Gold, silver are they show best ductility and best malleability, followed by copper, etc. So these things are there as physical property of metals. Let me see. So that means metals are, let us go point first. Metals are solid at room temperature, number one. Number two, metals have got high melting point and boiling point. Number three, metals are malleable. Number four, metals are ductile. Metals are sonorous. Metals have got high density. Metals are good conductor of heat and electricity. So these are the points about metals physical property which you should know. Non-metals are just opposite. Non-metals are normally gaseous or solids at room temperature with lower density, lower melting point and boiling point. Non-metals are non-sonorous, non-ductile, non-malleable. Actually they are brittle. Most of them are poor conductor of electricity except for graphite, which is an allotrope of carbon. Graphite conducts electricity. And most of the non-metals are not so hard, but carbon, one of the allotropes of carbon, diamond, is known as the hardest substance known. So these exceptions also you should keep in your mind when you are studying. You should also know which is the heaviest metal, like it is being told that osmium is the heaviest metal. So, and also a few points, there are two liquid elements out of the 118 officially known. This number also fluctuates, but at present let us try to fix it to 118. Out of 118 elements known, there are non-metals and metals. So in the periodic table, when you have a look, the periodic table which is placed over here, the red color is metal. In between you see the metalloids, and then you see very few non-metals. Are you following? You have a look on this periodic table. Now you will see what are metalloids. So actually there is not fixed an agreed definition of metalloid, and now chemists or scientists, they have little bit of agreement and disagreement about metalloid. But anyway, some of the metalloids will be those elements which have got intermediate property between metals and non-metals. All right. And so you see germanium or arsenic or tellurium or antimony, all these things are considered to be metalloids. So metalloids are those elements, which show intermediate property between metal and non-metal. However, we accept them, most of them, the names which I have told you, a few of them, we accept that they have got intermediate property between metals and non-metals. However, some of the scientists will not be accepting those things. Chemists, all of them are not under a unison agreement about this grouping. But for 9th and for 10th standard, a little bit we should understand this, that basically there is a border where some of the elements will show intermediate property, and the list is there, you should know. So these are the few things about the properties of metals, and especially now you will be able to further go in this chapter. Metals are also having characteristic metallic luster, which you should understand. Metals shine quite a lot. Metal surfaces shine. You must have seen the shine in gold, you must have seen the shine in silver. So one of the important properties, apart from metals being ductile, malleable, sonorous, is that metals show characteristic metallic luster. Only one non-metal has got little lustrous surface, you can say. That is one of the allotropes of carbon, that is graphite. Graphite also shows that metallic luster, almost it resembles to grayish luster of a grey metal. Thank you.